Okay, so welcome. So in this example, we're going to find the centroid of a region. And so I didn't write out the whole problem, but I'm going to explain it to you. And then we'll jump right in. Okay, so what we're going to do is we're going to find the centroid. That's what they want us to do, find the centroid of a lamina that is bounded, or the region rather. So the region that is bounded above by this function, bounded below by the x-axis, over the interval from 0 to 4. Okay, so this is our lines a equals 0 and b equals, or x equals 0 and x equals 4. So we're going to find the centroid. So all we're going to do is first got to find the mass, right, of the system, the total mass. So we know the mass is rho times the integral from a to b of f of x dx. And incidentally, this should make sense because this is the area of a curve, right? The area under the curve, right? That between the curve and the x-axis. So this should look very familiar, right? This should be like, oh yeah, that makes sense. And then all we're going to do is take that area and we're going to multiply it by the density to get mass, right? So now, let's put in the pieces. So now we don't know rho, right? But let's just carry it and see what happens. So we got rho from 0 to 4 of f of x dx. And of course, this becomes what? Right? So we integrate that. So this is going to become x to the 3/2, right? So we're going to have 2/3 out here when we integrate. And this is going to be evaluated from 0 to 4. Okay, now, again, since this is 0, we're just going to get 0 here, so we'll just evaluate it at 4. And because we're just going to be subtracting off 0 anyway, so this is going to be 2/3 rho times 4 to the 3/2. Okay? And so what do we get? We get 2/3 times what? Well, this is the square root of 4 is 2, and 2 to the 3rd is 8. So we get 8, right? So we can multiply this by 8 and switch things around. And what do we get? We get 16/3 rho, right? So that's going to be our answer, 16/3 rho. All right, so there's our total mass. Now let's find m sub x. Okay, now m sub x in this case is going to be 1/2 rho, so I'm pulling the 1/2 out, but, oh, you know what? Yeah, let's just, for consistency. So we've got rho from a to b, and this is going to be f of x squared over 2 dx. And so now I'm going to pull the 1/2 out. So that's going to be 1/2 rho, and I'm going to, from 0 to 4, and this is going to be the square root of x, quantity squared, dx. Okay? And so what does this give us? Well, this gives us, this is going to become 1/2 rho, the integral from 0 to 4, and this is just going to become x dx, right? And so now if we integrate this, what are we going to get? We're going to get 1/2 times rho, and then this is just going to become what? 1/2 x squared, and we're going to evaluate that from 0 to 4, right? So this just becomes that. Okay, and now let's evaluate this. So the 1/2 times 1/2 becomes 1/4 rho, and 4 squared becomes 16, right? And of course, we're just going to subtract off 0 because the whole thing is just going to be 0, evaluated at 0. And so what does this moment become? Well, this moment becomes what? 16 divided by 4. So this is going to be 4 times rho. Okay? So we've got our total mass. We've got our moment with respect to the x-axis. So now, let's find m sub y. So that's going to be rho times the integral from a to b, and this time it's just going to be x times f of x dx. And so now this is going to equal rho times the integral from 0 to 4 of x times the square root of x dx, which is then going to become rho times the integral from 0 to 4, and then of course this is just going to become, well, x to the 1/2 times x to the 1, which, or 2/2, which is going to give us x to the 3/2. dx. Okay? And so that's going to equal what? Well, if we integrate this, this is going to become what? Rho. And this is going to become what? X to the 5/2, so this is going to be 2/5 times x to the 5/2 evaluated from 0 to 4. And again, we're just going to evaluate it at 4 because it's just 0 at 0. And so now, what do I get? Well, this becomes 2 to the 5th power, which is just 32. So in this case, I get 32 times 2, which is 64, so I get 64 over 5. Okay, so this gives me 64 over 5 times rho. Okay, so those are the pieces that I need. Okay, so now all I'm going to do is divide, right? Well, let's see what happens when we divide. So the x coordinate for the center of mass is equal to n sub y over m, which in this case is going to be what? M sub y is this. So it's going to be 64/5 rho divided by m, the total mass, which is 16/3 times rho. And look what happens to the two rows. They cancel. And so now this just becomes what? Well, I'm going to write this as a multiplication, so this is going to be 64/5 times 3/16. Well, 16 divides 64, so this becomes 1, and 16 64 divided by 16 is 4. And so this becomes 12 fifths. Okay? And then y bar, what happens to y bar? Well, y bar equals m sub x over m. And so what's m sub x? M sub x is 4 rho, so 4 times rho, divided by, again, 16 thirds times rho. And of course, if I write this as multiplication, so this is going to be 4 rho, oh, hold on, the rows cancel again, obviously. And so what does this become? This becomes 4 over 1 times 3/16. And of course, the 4 and the 16 cancel each other out, so 4 divided by 4 is 1, 16 divided by 4 is 4, and I get 3/4. And so now the centroid is located at what? It's going to be 12 fifths, comma, 3/4. And I'm done. That's the answer. So notice that the density canceled out. Okay? And when you're dealing with constant density, this will always happen. The density will always cancel out. Because as you can see, the density is constant, gets pulled out of each piece, and then you're dividing two pieces, and so the rows are always going to cancel out when you're dealing with constant density. Okay? But again, make sure you keep them in there anyway, just you don't want to forget them, because what happens when we decide that we don't have constant density? Okay? So just because they cancel out at the end, always keep them in there, again, just to remember the formulas. Okay? Okay, now here's one for you. So let's say we have a region, R, and it's bounded above by the function f of x equal to x squared, and it's bounded below by the x-axis and over the interval from 0 to 2. Find the centroid of this region with the associated lamina of this region. And that's it. Again, if you have any questions, reach out to me. If you get stuck or want to find out what the correct answer is, reach out to me. I'll let you know. Have a great day.